All right, so here's our starter for today. And I decided to create a problem that's kind of generic to the dragging crate problem. We've got several problems that we're going to be looking at on the test. One of them is something moving on a horizontal surface. Another one is like the elevator problem. But if you have a problem like this, I mean, here's what we've got. We've got an object with a mass of m. It's being dragged to the right by a force F1. It's being opposed by F2, but it's also being opposed by friction. Here's the coefficient of friction. And it's moving to the right, and it's accelerating to the right. So what I want to do is apply the procedure we've been talking about to this situation. So the first thing we do, step one, is given, find, and solve with a picture. Well, I've already got the picture, so I'll just cheat a little bit and write given. Find, well, we don't know what we're trying to find here. That's kind of the point of this. And we're not going to solve for anything yet. But step two of the procedure is to draw the free body diagram. So you look at the crate, you draw a picture of the crate, and you say, all right, what are the forces acting on the crate? Well, obviously we got gravity pulling it down. M times G, right, is the force of gravity pulling it down. It's not sinking into the ground, right? There's an interaction between this surface and the crate that's holding it up. We call that interaction the normal force. Then you've got somebody pulling on it right here. I think you can see a little ghosty picture. I was going to draw a little person pulling on it, but I decided that would take too long to draw. But somebody's pulling on it with a big force F1, we're going to call that. Then we've got another person pulling it to the left, like maybe this is a tug of war or something, with this much smaller force of F2. Now, because I told you the crate is moving to the right, and I gave you a coefficient of friction, this tells us that there is a kinetic friction force acting on the crate. And what direction will it be in? Well, since the crate is moving to the right, that force of friction will oppose that. It'll oppose the direction of motion. And so here we go. These are all the forces acting on the object. I'm done with the free body diagram. And let's make this the x direction and this the y direction. And if I know the direction of the acceleration, I always try to make my positive x or positive y direction in the direction of the acceleration. You don't have to, just usually makes it a little bit easier to solve the problem. So I'm going to make positive x to the right, which is pretty standard. All right, now comes step 4. If we sum the forces in the x direction, that will equal ma in the x direction. Just do that. Just write this out. It's like a little instruction on what to do. Sum the forces, but only in the x direction. All right, let's do that. Well, I've got 1, 2, 3 forces in the x direction. I've got F1. But then I've got F2 and the force of friction pulling to the left, which is in the negative x direction. So instead of going plus a negative force, I'll just subtract. So this is going to be, well, this is F1 minus F2 minus the force of friction equals ma. Now, do we have acceleration in the x direction? Yes, we do. So this is it. Now, but we also need to sum the forces in the y direction. Equals ma in the y direction. Look in the y direction on here. You've got the normal force minus our weight equals 0. because in this problem there is no acceleration in the y direction. What this tells us, now by the way, based on what I asked, you could stop here. Okay? But there are some things you can note generically for this problem. This just tells us that the normal force is equal to the weight. What else do we need to know? Usually to solve a problem, that this force of friction is equal to mu times the normal force. So if I wanted, I could make this a little bit more, a little bit more specific. This is F1 minus F2 minus the force of friction, which is mu times the normal force, but the normal force is equal to mg equals ma. So using this and then getting this far and then using this equation, we end up with this. And this is the key equation for this problem right here. Now what could I ask you? What could I ask you to find? Well, I could ask you to solve for the acceleration. Of course, I'd have to give you the mass in F1 and F2. Or I could give you the acceleration and ask you to find F2 and give, I mean, look, you've got 1, 2, 3, 4, 5 things here. In order to solve this, I have to give you 4 of them. Now, which one am I going to ask you to find when we take the test? I don't know. But do you see that it's actually pretty much algebra 1 after this step? It's just solving for the unknown. That'll be step 5. So this is the procedure I want you to know how to do generically, and then after that it's just, and by the way, out of 10 points, let's say you got this far and then you screwed this up, you're probably going to get at least 7 or 8 points out of 10 on a problem. So the right answer is only worth 1 point. Showing you know all the steps is worth the most points.